Hey, everyone, and welcome to episode 171 of the Tick Bootcamp podcast. The title of today's interview is The Lyme Doctor's Doctor, an interview with Dr. Alan MacDonald. My name is Richard Johannesson.
And I'm Matt Sabatello.
So, Matt, this is another one of the Lyme pioneers. This is a guy who in the late 70s and the early 80s was out there on his own trying to come up with solutions to the Lyme problem that was created on Long Island, New York. And he was ostracized, he was mocked, he was mistreated. And as it turns out, he was really a sage.
And Rich, what was really surprising about this interview for me is that Dr. MacDonald proved things decades ago that are now coming to reality today with mainstream Lyme news. For example, he talked about the connection between Lyme and cancer, the mother-to-child transmission of Lyme disease. He even talked about sexually transmitted Lyme and studies that prove sexual transmission of Lyme. He also talked about the connection between Lyme disease, Alzheimer's, dementia, and MS. He talked about the important role parasites, both round and flat parasites, play in Lyme disease and keeping people chronically sick from Lyme. He went into blood transfusions and different strains of Lyme that people can be infected with throughout the world. And he also talked about the importance of biofilm. This podcast interview was just chock full of information and is a must listen to.
This is a must listen to for anybody who has chronic Lyme disease, because Dr. MacDonald is going to show you why you're having challenges getting diagnosed, what the challenges are in the medical community, and what you need to do in order to be able to make sure that you're treated properly by your medical doctor. So without further ado, another one of the Lyme pioneers, the Lyme Doctor's Doctor, Dr. Alan MacDonald. Hello, Dr. MacDonald, and welcome to the Tick Bootcamp podcast.
I thank you for inviting me.
Well, we're really excited to have you. Matt and I have been geeking out on all things MacDonald for the last couple of weeks, so we're glad to finally have you on the podcast. So, Dr. MacDonald, can you first share with our listeners where you currently live?
I'm retired in Naples, Florida.
And we understand that you were a Long Islander for many years.
Yes, I started my professional career on Long Island. I moved from NYU Medical Center to Southampton, and I was able to get a job there as a young pathologist. That was in the time when the work of Bergdorfer was going on and he was about to publish his paper. So I was in Southampton at the time when the Lyme disease hit the news and the medical journals.
And we're going to get there in a second, but I'd like to talk a little bit more about your background. So where did you grow up?
Grew up in Connecticut. We were in Manchester, Connecticut, near Hartford. And then I went to school at Tufts University. And I then went from Tufts University to Columbia College of Physicians and Surgeons. And
after you graduated from Columbia, what was your concentration? Meaning, I know you're a medical doctor, but what was your concentration?
I started in internal medicine, and then I switched to pathology after the first year. And I did my pathology training partly at Columbia Presbyterian, and then at New York University Bellevue, where I was chief resident, and there for 3 years.
So now let's talk about pathology. We've not had a pathologist on our podcast before, so can you define what a pathologist is?
A pathologist is a physician who is entirely obsessed with diagnoses, doesn't really interact with patients, doesn't write prescriptions, but we tell the doctors what is going on with the blood, the biopsies, the blood banking, the microbiology. So we're sort of a diagnostic specialty, and some people call us the doctor's doctor.
All right. So you were working as a doctor's doctor in the early 80s on Long Island when the Lyme World, I guess, started, right?
Yes, I was contacted by Dr. Jorge Banach, and he is now a world authority. He was a young professor at Stony Brook. He came out to get our medical staff interested in the area of Lyme disease because the tick that carries the disease had been identified from ticks that lived on Shelter Island, and Shelter Island was only 10 miles away from, or 5 miles away from the hospital. So we were going to be knee deep in Lyme disease ticks, and they wanted everybody in our medical staff to start looking for signs of Lyme disease in their specialty. Now, I was lucky to have Bernie Berger. Dr. Berger was a world expert on the skin erythema migrans, and he worked with the NYU team of Bernard Ackerman to show that the spirochete was in the skin lesions, the erythema migrans. So he was a friend, and Joe Briscano was there, and other members of the medical staff were all interested in Lyme disease, and they all got their original Lyme testing from me because I had to set up a hospital lab to test for it. We used fluorescence to find antibodies. So before it was available from labs or from the New York State Department of Health, I was doing Lyme testing at Southampton Hospital.
So now let's talk about your interaction with Dr. Banach and Dr. Bergdorfer and that group. Were you interacting with these folks when they were testing the initial ticks that Dr. Banach had located when he was doing the drags on Shelter Island?
No, I came in afterwards. I came in after the identification of the B31 strain, which is the strain of spirochete that was removed from a tick on Shelter Island. And the B31 is really a code name for the three Bs: Bergdorfer, Banach, and Barber. And so that one was the basis for many blood tests today. It's a tick that never saw a human body, but it's a tick spirochete that is used to diagnose all potential forms of antibodies in all human patients. So it's sort of an awkward sort of a fit.
Well, let's talk about that awkward fit, because one of the people we interviewed on this podcast is the author, Chris Newby. And she spent a fair amount of time studying the history and interaction between the three Bs for the 3B Borrelia. And one of the things that she was concerned about and raised in her book was whether or not, in fact, chronic Lyme disease is caused by that bacteria, or is it actually caused by a Rickettsia Swiss agent US. Do you have any thoughts on that, and why the three of these folks who are now credited for having discovered the Lyme bacteria were debating about a Rickettsia that they ultimately did not settle on?
I read Chris's book. I know Chris for many years, and I've got a view that most of what she has in the book is accurate. As far as the Rickettsia connection, the Rickettsia do damage by burrowing into these cells that line the blood vessel, and those are called endothelial cells, and so they kill those cells off. And then because of that, you get the red spots on the skin and palms of the hands, and then you can get organ failure and death from Rocky Mountain spotted fever. Now, the Rickettsia that is the Swiss agent may not be as nasty, but by definition, it has to live inside cells. And I think that we have enough evidence with my Lyme autopsies that the other kid in town, which is a spirochete, which lives outside of cells or sometimes inside of cells, can do damage outside of the cells as lethal as the Rocky Mountain agent. So it's sort of a gamish and a mixture. I don't really have a final view of what is prevailing.
Okay, so let's talk about a definition of Lyme disease while we're here, and that is, do you believe Lyme disease is a polymicrobial infection or a multi-germ infection, or do you believe it's an infection caused by a single bacteria?
I think that the prevailing evidence now is that the tick that transmits the spirochete has a gut full of other nasty microbes. And therefore, that tick can transmit other nasty things like Ehrlichia and anaplasmosis. And those things don't have a big horizon of visibility. So I think that you would say, just based on spirochetes to other non-spirochetal things, that it's polymicrobial until proven otherwise. I would say that even within the spirochete area, there are different substrains of Borrelia that can coexist in one patient or in one tick. So you can have 3 in 1, 4 in 1. So the idea of just a B31 spirochete, which in effect may not actually cause human disease, but something like it, is not the sole answer to what's going on. Now we have also Borrelia miyamotoi, which is capable of coexisting in a patient with Lyme disease. So you have a double infection there. So I would say think plural, don't think singular.
So let's talk about what you were doing as a pathologist at these, during these foundational events. And can you talk to us specifically about the testing that you were developing, specifically the fish testing?
Well, the fish testing came later, but the first thing I had to do was to prove that I was able to find and validate the bugs in tissue. So I was looking at dead babies and miscarriages, and I found that the percentage of them were infected with the Lyme agent. Now, in order to find that in the microscope, you would do a silver stain, and that makes the spirochetes color brown or black, and then the background tissue looks yellow. So it's a nice contrast. But I wanted to do better, and I developed an immunofluorescence test, so it glows in the dark under a fluorescent microscope. And I was convinced that I had to prove my skills. So I asked Banach to send some coded specimens of hamster and lab infected, non-infected, and they were autopsied. And they sent the organs to me. And I used my fluorescence test. I got a 100% score. So I validated my own method at that time. And I used fluorescence to find evidence of spirochetes in dead babies and in the skin of Lyme disease patients with Dr. Berger, and in blood and in spinal fluid and other specimens. So that's how I got going with a microscope piece.
So let's walk that back a little bit. You said that you began to do your research on the autopsies of dead babies. Now, to this date, in 2021, there is some debate about whether or not Lyme disease can be transmitted in utero. Yet in the early 80s, you were already definitively proving that dead babies were in fact infected by Lyme disease. So can you talk about why we've made so little progress in at least mainstream medicine accepting the findings that you had made in the 1980s?
Well, the discovery came because Lyme disease is just like syphilis, and syphilis could kill babies. And because babies with syphilis could be aborted or stillborn or born with, a short lifespan and then die on the second day, or worse yet, live into adult lifehood, if that model is disputed, and it may be disputed by some, that syphilis can't cross the placenta, then you have an uphill battle to try to talk to people about Lyme disease crossing the placenta. The only way that the bug gets into a fetal heart or into a fetal brain, like I showed in my, dead babies, was it had to cross the placenta from mother to baby. The babies don't live outside the uterus. So it's very, very simple. And I could find the bugs in the placenta, and I could find the bugs in the umbilical cord blood, mother and of baby. So I don't know what the dispute is. I think that some of the people who argue that there's no connection use their argument based on, well, there's no antibody positive pregnant lady number that we can find out there for people who have done a cursory look. I'm not dealing with antibodies. I'm dealing with dead babies and bugs and tissue. There's only one way to get there. It's going across the placenta.
So you were working, I guess, as a doctor's doctor. You're sort of in between being a clinician and a researcher, right? You're sort of in that I guess in between the two. Were you publishing any of your findings that you were doing first when you were doing the research on or making your clinical findings on the fetuses that you were examining?
Yes, I published the dead babies work in 1985, 86, because I went to Vienna, Austria, at an international symposium on Lyme disease in Vienna. I presented my work. I had 5 minutes to show my results. I presented 100 pictures of spirochetes and dead babies in 5 minutes. And the people in the auditorium didn't ask me a single question. They just walked out and took a coffee break after that. Nobody asked me anything because they didn't believe that my work was real. They thought that I had manufactured the paper, manufactured the pictures, fraudulently presented this data, and that I was a fraud.
And why did they believe that you would have been fraudulently presenting this information? I mean, why is there, from the very beginning, so much resistance to strong data that was being developed by doctors like you?
Alan Steer accused me of medical fraud. And Alan Steer holds a huge, position in the community. And, when I published my Alzheimer work, I got Alzheimer brains. That was when I came back from Vienna. I wanted to do the Alzheimer work. So I got Alzheimer brains from George Glenner's brain bank, and they were frozen, and I got them, I thawed them, and I did the microscopic study of spirochetes in the Alzheimer brain sites. And I also cultured the spirochetes from the Alzheimer brain, and I published that in the Journal of the American Medical Association in 1986. He was a reviewer on the case, and his comments to the editors were, this work, if true, would be significant. However, the appearance that he has in these pictures of spirochetes are those of spirochetes in culture. Well, my paper was about culture. So he was trying to say in a veiled way that I had taken spirochetes from a culture from a human somewhere else and then tried to pass them off as spirochetes that I grew from Alzheimer brain and fraudulent. The JAMA editors did not buy that. So I got published.
So let's talk about Stier, because there are many in the Lyme community that consider him a Lyme villain, and it's interesting that Dr. Stier, who's a rheumatologist, certainly was present when the pattern was shared with him by Polly Murray. He did see the cluster, but why did he go from being a rheumatologist who observed a cluster to becoming the guy who's now, I guess, the gatekeeper for all research that was being done, even by pathologists in the 80s and the 90s?
Well, he was a young investigator out of the CDC, the EIS officer. It's a corps of officers that are MDs, and then they spend time at the CDC, and then they go into academic practice. So he was a young graduate of the CDC. He went to Yale. He was approached by Holly Murray and don't forget Judith Mensch, and they told him about the knee problem in the children, in their children, and the people were really a cluster of arthritis patients, most of them juvenile, in Lyme, Connecticut. Now, remember, there's a dispute now about chronic Lyme disease. You know about that, right? Chronic is very disputed. Every single one of the joints in Lyme, Connecticut that Stier looked at was a chronic infected pediatric patient. Let's go back. Chronic and arthritis are always chronic. It's not acute.
So let's
choke on that a little bit. Let's choke on that a little bit.
Yes, we are going to have to choke on that a little bit and wonder why folks like you were making the observations, the findings you were making in the 80s, and this has become a pandemic, which perhaps could have been stopped had your research been given the credit it is now being given, but should have been given in the 80s. And so I want to explore that a little bit more with you. And let's talk about the objective findings that you were making, because one of the things that our community finds really frustrating is that it's very difficult to objectively test to determine whether or not you have Lyme disease. But it sounds to us like you were able to objectively test for the existence of the various parasites, bacteria, and viruses back in the early 80s, and we've not been able to convert that into a testing protocol that would allow people to be properly and objectively diagnosed. So talk to us about how you developed the testing you did and why you believe that has not become a standard, a diagnostic standard in 2021.
Well, it takes me back to Southampton and working with Joe Burrascano, who was a great friend and had a great interest in looking at things scientifically. So I requested that he send me some bloods from his patients who were either under treatment or before treatment or after treatment. And I had the medium, the BSK culture medium, I had manufactured that from dry chemicals because I had the formula from Bergdorfer. So I had a supply of culture medium, and I cultured the blood, and I found that spirochetes were present in the blood of his patients, either before, during, and sometimes after the therapy. And then we looked at these cases together, and he'd come in and look under the microscope, and he'd see the spirochetes moving and say, okay, now I understand that I will have to continue my therapy until the spirochetes are gone. And that helped him to develop some of his guidance for his treatment. The spirochete of syphilis does not grow in laboratory medium, but the spirochete of Lyme disease does. And so my culture method worked well for him and helped me to understand things about how the spirochetes behave in the blood. And I used that effort to then take it and culture skin biopsies from Bernie Berger's erythema migrans, and I could grow spirochetes from 20 of those patients. And I sent them out to Rocky Mountain Lab, and some of them were different from, had individual differences from case to case. So they used those to study. And the culture in general has been, in the proper hands, a very useful tool, but it has been disputed by the CDC as being fraudulent and irresponsible and unscientific and not to be trusted. So the CDC came in and poured cold water on the idea of cultures. Now, all of my work that I've ever done and will ever do is always free. I have never charged anybody for any of my work. That's not true for some of the other people in the field. But I think that this is my way of giving back to the community.
So, Dr. MacDonald, you had a better Lyme test than any that are out today, and the CDC shut it down by making false accusations, and it could have been helping people for probably the last several decades, it sounds like.
In my opinion, it could have helped a number of people. I could culture spinal fluid when there were no antibodies and grow spirochetes from spinal fluid. They were reluctant to endorse that. I could get it from blood. I could get it from synovial fluid. I could get it from amniotic fluid. It is the CDC with a heavy hammer saying that until they approve something, it is untrustworthy. And that's maybe not fair science. I mean, it may be that they would review my paper negatively when somebody else would review it positively, but because of the heavy hand that they have, they could shut down everything that has to do with some of these new ideas.
And this was around the same time that many Lyme literate doctors were being shut down. They were losing their medical licenses, and chronic Lyme was being was literally under attack by the CDC and the government, correct?
Correct.
So talk to us a little bit more about Lyme and blood transfusions, because we do know that many people here in New York even get blood transfusions from Europe, people in Europe. Is there a possibility that people who get blood transfusions can get tick-borne illnesses from those blood transfusions?
There's a scientific basis to say that the Borrelia spirochete can survive in banked blood. So that's a benchmark that's been published. That's peer reviewed. So if you take a unit of blood that's in the blood bank and you put some spirochetes into it, the spirochetes can grow and survive in that unit of bank blood. Now, the second piece is that one of the co-travelers for Lyme disease is babesiosis. And in Eastern Long Island, not only do we have a hot spot for Lyme, we have a hot spot for babesiosis. So I collected 100 cases of babesiosis in patients who were coming to the hospital. And I found that those patients, none of them had an antibody-dependent diagnosis. They were all diagnosed by my identification of the babesia inside the red blood cell. So they were all microscopic positive. And because babesiosis early on was shown to be capable of transmission by blood transfusion, there were a bunch of people who got very sick and almost died from babesiosis contaminated blood back in the 80s and 90s. And the CDC had a registry about that. Now, it's not really much of a big step to say, well, if the body has blood and if the blood is infected, and if some of the infection is inside the red blood cells like babesia, and then you could have a possibility of Borrelia spirochetes outside the red blood cells, that if you can have transfusion, transmitted babesiosis, you can have transfusion, transmitted borreliosis or Lyme disease, period. It's not a big step. The connection to Europe was something I brought up way back with the New York Times and a letter to the editor. And I said that at that time, we were getting about 60% of our blood for the New York Blood Centers from European donors. It was shipped over by air freight. So that opened up the possibility that European type Borrelia, which we don't have here in the US yet, could be in some of those units theoretically. And certainly American type Borrelia and American type Babesia, we know the Babesia was already there in the blood supply. So why not say, let's look at blood transfusion transmitted Lyme.
But Dr. MacDonald, is the current testing for Lyme disease, I don't believe, is looking for European strains of borreliosis. Is that correct?
There are some special techniques now that you can use. If you get a European test kit, then you can do testing for European strains in the United States. But most of that testing is done in Europe. They have a test kit for Rickettsia, another test kit for Afzelia, another test kit for the European variety of Bergdorferi, which is a Dutch kind of thing. And so you can get test kits for each of the substrains in Europe. I think right now, my personal view, it hasn't been proven, but I think right now that we already have Rickettsia here in the United States, and it's not being diagnosed because it's transmitted by birds, the ticks that carry it. So they fly up and down the coast, and they could leave their new strain anywhere that they land. It's also present in Brazil. Rickettsia is present in Brazil, and Rickettsia is present in Mexico. So we could say that maybe Trump's wall would keep the Rickettsia in Mexico from getting across to the US, but I'm not sure that's true.
But what I'm hearing is that many of these other strains of Lyme disease can be causing people to be sick in the United States and here in New York. But the standard testing, like I would get at a LabCorp or a Quest lab for my doctor, probably isn't testing for these other strains, and they can be or could be the contributing factor to my illness potentially.
And they would test negative with American test kit strains. Yes.
So I think it's important for our listeners to understand that if they are sick and they did have a blood transfusion or they're just focusing on the Lyme testing, they should broaden their horizons to potentially other strains of Lyme disease and other co-infections, and maybe use a more specialized lab like IGeneX or another lab that can test a more diverse set of bacteria and pathogens from a tick-borne illness.
Reasonable to say that. And also remember, if you go camping in Europe and you get bitten by a European tick and then come back and get sick in the US, and that has happened, and those patients have been tested and were negative, that you could have a European infection in the US, which you acquired by vacation.
So let's talk a little bit more about testing and the different forms the Lyme bacteria can actually fold into or form into. So we know there are spirochetes. It's pretty well known out there for most of our listeners, but we also know that there's this cell deficient form called the L form and the round circular form of the Lyme bacteria as well. But the Lyme testing really is not very good at all for those other two forms aside from the spirochete form. Is that correct?
That's true, but it hasn't actually been rigorously tested in laboratory stuff. The people who did a lot of the work on the round body or the cyst form were the Brosens, and they were in Norway. And they did their work, 1990s, I guess. I published my paper, the first paper on cyst forms of Borrelia in the world was my paper. And I found one of those in an Alzheimer brain. So I put cyst forms on the map, and anything that I put on the map is problematic because I'm not to be trustworthy. So yes, cyst forms, L forms, that's even more of a reach. They also are true. I found them in blood and in tissue, and they look like amoeba rather than little nice round things. They have very plastic form, so it varies enormously. So those are also not going to react in conventional Lyme blood tests. So in addition to those two forms, the cystic form, round body form, and the L form, there is now the biofilm form. We can get into that.
So Dr. MacDonald, before we go into the biofilm form, I do want to ask that many people we've spoken to on this podcast have told us that there are techniques or tools people can use to activate the spirochete form of the bacteria. So when they get their test, they have a higher chance of testing positive for this illness. Is that something that you think is a valid point where there are either supplements or things we can do to bring out the spirochetal form to have a higher likelihood of testing positive if we're sick from Lyme disease?
I'm not sure. I think that it's interesting to see if you could provoke some way to provoke the increase in the number of units in infective units in the blood, so that if you have like a threshold for, I can detect 1,000 units in a blood sample, but I can't detect 100 units and I'll never detect 10 units. 10 units is still infectious. So we have a threshold situation. I'm not sure what can increase the number of particles or units, but there is one very inexpensive way that anybody can take advantage of. It's called a Buffy coat smear. And that is, and you take the blood, you spin it in a centrifuge, and the top layer has the white cells and the spirochetes. So instead of trying to find a needle in a haystack of unconcentrated, you do a Buffy coat smear of peripheral blood, and you'll see many, many more spirochetes per unit area. And it's an easier diagnosis because they're all concentrated at the top of the fluid after centrifugation in the Buffy coat layer. So I recommend that. Other people will say that that's another MacDonald crazy idea, but I know that it does work. I've used it successfully.
So some of our listeners want to use that approach. Should they ask their doctors to run a Buffy coat smear test? Is that something they can do? How would they actually move forward to get that test performed on their blood?
Well, the next hurdle after you get the Buffy coat done is to get a pathologist to look at it with the proper stains and the proper background to see what is actually present in the Buffy coat layer. If you find spiral forms, that's easy. If you find cystic forms that load around, they'll say, no, that's not real. If you find L forms, they'll say, no, that's not real. And if you find granular forms, which are little very minute salt and pepper flakes, those are also infectious, and those are also present in the Buffy coat layer. So if you're lucky and you have spiral forms only, you might have a chance. But if you have the other ones, you don't have a chance. The way to go for truth there is to use the DNA, because the DNA of the bug is preserved across all of the morphologic forms. And it's present, and it's a reliable indicator. So instead of looking for antibodies or maybe different chameleon forms of what the bug might look like in all its disguises, you can use DNA.
Many of the doctors that our guests go to are not familiar with a lot of this stuff. So to give them very specific guidance on how to get this testing done, is there a lab you recommend they send their blood to? Is there a specific protocol or keyword they should use as their doctor to get this test done? What advice could you give them to get this Buffy coat smear test done and to have it in a sort of shortcut way to help them get this test performed for them?
Unfortunately, there's no lab that is doing this Buffy coat approach right now. IGeneX might step into that equation because they're doing DNA detections for Borrelia with a FISH method. So it might be that if they get their method proved, they could use FISH on blood Buffy coat smears and be helpful to those patients. But as far as regular hospital labs, no. University hospital labs, no. Even Stony Brook, no. So it's more of a MacDonald kind of thing that is frowned upon.
So we should keep our eyes out for IGeneX to potentially adopt this down the road. And now, as far as you were talking earlier about biofilms as another form, right, of the Lyme bacteria. So talk to us about that, because biofilms, we've heard from some Lyme doctors, are not that big of a deal. We've heard from other Lyme doctors, they're huge and they must be addressed in order to recover. So where do you stand in that debate? And do you think they're really a big deal in healing from Lyme disease?
I was working with Eva Shoppy for many years after I moved out of New York. And Eva came up with the idea that Lyme disease spiral forms could become communities or culture plaques or colonies. And that was based on some work of Dr. Costerton, who's the father of biofilm biology and microbiology. So she allowed me to learn with her. And in 2006, we started to look for biofilms in Lyme disease. It took 12 years of work and to get the published article, which was in test tube proof that biofilms of Borrelia were real. So that happened in 2012. In 2008, I came up with the idea, since I knew what biofilms looked like, and we hadn't had the permission to publish it, came up with the idea that biofilms could be the structure that is responsible for Alzheimer plaques in the Alzheimer brain. And I proved that in 2010, that the Alzheimer brain plaques are biofilms covered by amyloid. But biofilms are also present in other chronic Lyme conditions. The one that we got published was a skin condition called Borrelia lymphocytoma. It's a European condition where instead of getting flat lesions on the skin, you get bump red type lesions on the skin and red hot ears and bumps on the nose and a hot nipple because the bugs in those sites tend to favor those specialized sites. And we found that biofilms were present in Borrelia lymphocytoma. We got that published. So that was 2016. It was another 4 years of struggle to get that published. Now, biofilms are the way bacteria in general, 99.7% of bacteria on planet Earth have a biofilm form. It's a way of circling the wagons, preventing the bugs from dying off in hostile, unfavorable conditions, and an adaptation to chronic disease. Biofilms, repeat after me, biofilms always indicate chronic infection, period, okay? Always chronic, never acute. Now, I found biofilms in scan with Dr. Shoppy. I found biofilms in Alzheimer disease brain plaques in autopsy brains. And then I started to look for biofilms in blood. And I found that although it's not supposed to be expected, you find biofilms circulating in the blood. I found biofilms in circulating blood from Alzheimer patients. And they are, let's just imagine the size. The red cell is 7 microns. The Borrelia spiral form is about 10 microns in its usual form. The biofilm communities are 200 microns in size. In order for the blood to get through the capillaries, the red cells have to bend over double because they have to go through a 0.3 micron diameter capillary channel to nourish the tissue. If a biofilm huge community hits a capillary bed, it is not going to get across. It's going to get blocked. And what happens if you block the blood supply to a tissue? You get little areas of mini death, mini infarction. So some of the total body pain syndromes of people who have Lyme disease may be biofilms hitting capillary beds all across the body and causing all kinds of havoc. So the biofilms in blood are real. I have found biofilms in blood of patients who have quote unquote chronic seronegative Lyme disease. I've used my DNA probes to prove that they're Borrelia rather than just stain it with ordinary protein stain. I used DNA probes to prove that the Borrelia DNA is inside the biofilm. So biofilms are a very menacing thing. They are always important. They are always chronic, and they may be life-ending if, God forbid, you get something like Alzheimer's.
So, Dr. MacDonald, I want to bring this down to a sort of a practical observation here as somebody who is an almost native Long Islander. I've been living here since I'm 2 years old. I've been getting bitten by ticks during the entirety of my life. Certainly in the 70s when I was growing up on Long Island, I was bitten by ticks many, many times before the Borrelia bacteria was discovered. And one of the things that I'm finding a little frustrating, I was bitten by ticks several times, and the most recently, a couple of weeks ago, my sister was bitten by a tick yesterday. And despite all of the groundbreaking work being done by you and Dr. Bioroscano and Dr. Berger here on Long Island, there are no Lyme literate doctors here. You know, when I'm looking to go to a doctor, when I was bitten this year, I consulted with a doctor in North Carolina. Last year, I consulted with a doctor in Chicago. I didn't know who to send my sister to when she was bitten 2 days ago by a tick. Why don't we have any Lyme literate doctors here when all of the foundational work was being done by you folks in the 80s?
I don't know why people set up practice in areas where they decide to set up practice. Some of it is that, you know, you have environments where you are welcomed, and then there are environments where you're not welcomed. So if there's a political basis of, let's say, persecution, if you have a belief system that violates the existing norms, then you might want to practice somewhere where it's a little more friendly. That's all I can say about that. I think that politics has a lot to do with where people settle or where they continue to practice. My friends who are my age, I'm 73, are still practicing in Westchester and upper there, and of course Steve Phillips in Connecticut, so I will send people to those friends of mine, but there might be other doctors who are special interest doctors in the Lyme area. In Long Island now today, I can't say that they are not present there.
So, you would think, in a place like Long Island, that not only would there be specialists, which I can tell you there are none, but you would expect that the general practitioner who would be treating people who are bitten by ticks would have an understanding of what steps they should take in order to protect us from becoming chronically ill. And I can tell you that the inspiration of this podcast was after I represented Matt, who almost lost his job because he was chronically ill and couldn't go to work for a period of time. I was bitten by a tick, and I went to my doctor's office, and my doctor's office first wouldn't allow me to make an appointment, told me I wasn't ill, so I didn't need to come in. And then when I jumped up and down and I demanded an appointment, it was clear that they were incompetent, and that became the trigger for not just this podcast, but this obsession that Matt and I have now for trying to come up with vehicles for stopping this pandemic from becoming worse. So why do you think the average doctor is either not able or willing here on Long Island to treat people who are bitten by ticks?
Well, Dr. Bergdorfer almost lost his license because of his belief of, a Lyme disease illness that sort of corresponds with my belief of a Lyme disease illness, which is a chronic condition. I think other doctors have been alarmed by the fact that they can be brought up on charges of doing quote unquote bad medicine because they're doing quote unquote Lyme disease care. And therefore they'll focus their efforts elsewhere and encourage the patients to go elsewhere. And that's okay if the politics has created a toxic environment. You don't have to do everything in medicine. You just have to know where to send the patient to get good care. So I don't treat any patients at all. So, I'm kind of useless, but I know where to send patients who have specific problems. And so that's maybe what the Long Island doctors should do, is to develop a referral system for people they have confidence in and not try to take on the politics.
So, but Dr. MacDonald, anyone who's been listening to this podcast can tell that you're a brilliant man. Clearly, you're an Ivy League educated doctor who has come up with a number of very creative ways of analyzing what was a new problem in the late 70s and the early 80s. But one of the things that's really breaking my heart as we're having this conversation is so much of what you were doing in the early 80s has now become the basis of the Lyme treatment and Lyme diagnostic community. You were considered crazy when you're doing then. It's now becoming more and more mainstream. And we unfortunately have a whole generation of people who are getting sick and can't get the treatment that they need because of the politics. So I think we really have to spend some time exploring this because, most people want to continue to earn a living when they're practicing medicine. Most people want to continue to treat their patients, and they're actually being discouraged, in fact, maybe even worse, rewarded for not properly treating people with Lyme disease. So we really have to explore the challenges that were being created, more than just, feeling badly for you because you keep saying, during this podcast, well, this is a crazy MacDonald thing and it's another crazy MacDonald thing. So they've certainly already invaded your emotional thought processes. But I think it's a bigger problem because so many of the people that we talk to have to go from doctor to doctor to doctor. We interviewed a young woman whose mother had to take her to 50 different doctors before she was properly diagnosed with Lyme disease. Your fellow alumni, Dr. Fallon, has done some research that showed that the average child has to see 7 different doctors before he, she, or they are diagnosed with Lyme disease. So we really have to explore this in more detail about why there is this desire to punish doctors who are treating people with Lyme disease.
The politics have waxed and waned, but usually they've waned. On the side of less awareness of major health problems that are related to Lyme disease, less awareness of the chronic, what we call morbidity, not mortality, and then maybe the denial that there could ever be a fatality in Lyme disease. Those are all things that happen. They weigh in politically. If you are a subject for medical malpractice because you failed to diagnose and then the patient had some kind of terrible complication or even died, you will have to defend yourself in court. The medical malpractice activity, which is greatest in the United States now, is from the Infectious Disease Society of America persecuting Lyme doctors who treat patients who are trying to deal with chronic health problems. So all the expert witnesses are anti, physician who treats chronic Lyme patients, and therefore there's another dimension because there's a bunch of there are a bunch of people who will make a living testifying in court against doctors who do exactly what you want some Long Island doctors to do with chronic Lyme disease.
So we have this sort of multi-dimensional problem. The first dimension of the problem is we have medical schools failing to properly train doctors. And I'd like to talk a little bit more about the parasitic element of the training. We have doctors who are not being trained when they graduate from medical school. We have doctors who want to properly treat their patients, but they're afraid that they're either going to be sued or the education department is going to try to take away their license. So, what do we do here? How do we get people in a position where they can be properly diagnosed and properly treated, short of seeing at least 8 doctors when they have Lyme disease?
I think that the access to published peer review publication in quote unquote good medical journals would be a place that we'd want to try to make some progress in that area. Right now, the articles that are submitted that are in the general realm of chronic or disability type situations after Lyme disease misdiagnosis are not allowed to be published. The reviewers are all on the other side, which is the STEER and CDC camp. So we have to sort of find a solution to that. And I think that Willie Bergdorfer used to say to me, you got to be very careful because they will squash you like a bug. But he said, on the other hand, even though you're walking on thin ice, the ice is getting thicker every day. And I think about that, walking on thin ice and thick ice, and I think there'll be a time when the ice is thick enough to drive a semi onto the ice and it won't crash through. But right now we're still on thin ice when we try to make points about chronic Lyme disease as a real illness, deaths in Lyme disease, and physician responsibility for providing care. Most of the care that's needed is not for the early stuff. Most of the care that's needed is for the chronic stuff, period. So if chronic is going to get you drummed out of medical school or drummed out of medical practice or into court, people don't want to take that giant on. They don't. But the biggest public health need is in the area of chronic Lyme disease related patient care, diagnosis patient care.
Now, before we go there, and I really do want to explore that with you because I think that's an important next step, but I'd like you to explain to our listeners, what is the relationship between publications, which you are currently being either limited or precluded from participating in, and clinical care, and why should the average patient care about the publication arena that you just identified?
The articles that come in the New England Journal of Medicine and the top tier medical journals like that are controlled by the people who are Dr. Steer and Infectious Disease Society of America aficionados. So they have a stranglehold on what gets published, and what gets published in top tier journals becomes quote unquote the truth, the trustworthy, the
standard of care.
The standard of care. We've got to show that the standard of care is being standard of care is actually caring for the patient is being transgressed because the sickest people are not getting care. So you got to focus on not just the public view of publications of what they want you to believe as, there's no problem, it's, easy to cure, it's hard to get. Turn that around, it's hard to cure and, could be fatal. We have to turn that equation around. And some of it is under our skin type videos, other educational videos. You may have seen me in one or more of those.
I have.
People do watch that and people do pay attention. So that's a way to, maybe bypass, like the drug companies, they bypass the physician and they tell the patient, ask your doctor about Linzess if you're having trouble. They should say, ask your doctor about, I need some supported diagnosis for my chronic Lyme condition. Do that, just like the drug companies do. Have the patients ask the doctor. And then
let's pause there for a second. Dr. MacDonald, let's pause there for a second because I want to flesh out this standard of care issue, right? Because what's happening is people like you who are doing the research that you're doing are being precluded from having access to the journals which are going to establish the standard of care. So if you are not able to affect the standard of care, if a doctor, a clinician who is interfacing with patients is going to use a standard of care that does not include your research or research like yours, then that puts that doctor in a position where they are more likely to be sued and they're more likely to be subject to being sanctioned by education departments because the standard of care is being set by a political subset of the medical community.
Yeah, perfect. I mean, you couldn't have done better in crystallizing that. That's exactly the problem, is that what is patient-centered care should be supported, even if the patient comes in with a politically vexing situation. You should care for the patient, don't care for the politics. Care for the patient, above all, do no harm. There is the harm of doing, and then the other side of the Hippocratic Oath is the harm of doing nothing. And unfortunately, I think we're going to need more attorneys to make the harm of doing nothing punishable in some way, because we haven't been able to succeed with scientific journals. So now we have to succeed with the legal profession. The legal profession helped us to get seatbelt laws because people didn't want to get seatbelts. And now we have seatbelt laws. And the legal profession has helped us with other things that are important in the realm of a better quality of life. So maybe that's what we need.
So let me explore this one last piece with you before we move on, and that is, now what a clinician is supposed to be doing is looking at the standard of care and then determining whether or not their patient is an outlier on one side or the other of the standard of care. Now, if the standard of care is perverse, meaning the well-documented research from people like you are not being made available to the clinicians because they're not being published in reputable journals, then it makes it even more difficult to treat somebody who may be an outlier, which is what a clinician is supposed to be looking for. So we have this dual problem of having a perverse standard of care, and then we have, unfortunately, legal and administrative or governmental sanctions for somebody who wants to now treat their patient who may be outside of the population where the standard of care was established.
Perfectly said, perfectly. I think that acceptance of tests where the blood tells a story other than antibody positive, antibody negative. The blood now can tell a story. Spirochetes are present in blood, even though the antibodies are negative. If we can start to use some of those tools, and my fluorescence in situ hybridization DNA tools can make diagnoses of spirochetes positive in blood, even if the antibodies are negative. Spirochetes in blood are proof positive that you have an infection. And in the old days, we used to use gram stain to look for bugs in blood and tissue and fluids and stuff. It's the equivalent, the 21st century equivalent of the gram stain. Find the spirochetes in blood. They are there, and biofilms are there, and Miyamotoi Borrelia are there, and Bergdorferi are there. It may not be spiral, it may be it's a granular form, but it is announced by the fact that the DNA of the bug says, yes, it is what you think it is. The DNA of the bug only matches Borrelia. So if your DNA test is positive, that's what you want to know. You don't want to care whether your antibody test is negative or positive. You want to have DNA positive testing in the patient who is coming in for medical attention. And, I have some past research, which are rapid DNA tests that can be turned around in 5 minutes with specific, DNA probes only reacting with Borrelia that can tell you whether the DNA of the bug is there or not. But those tests would not be done for free. And because I've always done all my work for free, I couldn't take it to the level of, doing a patent on it or anything. I would never do a patent anyway, but the test methods are out there. I will give them away for free if somebody will just do it. I mean, I'm not here to make a profit. I'm just here to help people.
So Dr. MacDonald, let's now take the step that you started to take with us, which is this line between acute Lyme disease and chronic Lyme disease, right? And the challenges with essentially calling both diseases or both presentations Lyme, right? So I think the first problem that we have is a definitional problem with defining Lyme as a single bacterial infection or a polymicrobial infection. But now we're also calling this acute illness and this chronic illness the same name. And recently we interviewed Dr. Bill Rawls, and we interviewed Dr. Phillips on his book, Chronic. And what both of them told us is that they very rarely see someone going from an acute phase to a chronic phase unless they've been bitten by multiple ticks at the same time, or they're living in a chronic mold environment at the time that they're bitten by a tick. So rarely do we have someone going from acute to chronic. This chronic condition is something altogether different. So do you think first that it's a mistake to describe both acute and chronic Lyme disease as Lyme disease? And secondly, do you think that may be the reason why we have so much resistance to accepting chronic Lyme disease in a chronic form?
Okay, well, I've written about this too. I've written that it's time for a Lyme divorce. Whether you have an attorney help you with a divorce or somebody else, divorce yourself from the use of the word Lyme and call it Borrelia. Because in Europe, they have all kinds of Borrelia-related illnesses. They don't talk about Lyme in Europe. They get by very well with borreliosis, right? So call it borreliosis. And then, in Germany, past years, they had 1 million new cases of borreliosis in Germany in a year. So it's a big time thing. Here we have like 500,000, 450,000, maybe more, but, call it borreliosis. Get rid of, just drop the Lyme disease thing. That steers ticket to academic perpetuity, as he's the Lyme guy. All right, give him that and take back the infection and say it's borreliosis. And then that will get you over one hump. The other thing is that the Miyamotoi can exactly mimic many things in Lyme, and it's much more nasty. And it's not going to test positive with any of the antibodies. And you're going to have mixed Miyamotoi Borrelia and Bergdorferi Borrelia. And you have Bissetti Borrelia, which is coming up in the South and in Canada, and cases of those have been described. They are antibody negative and PCR positive. And you have your Mayoni, Borrelia Mayoni from the Mayo Clinic. That's usually PCR positive by necessity. So we're moving away from antibody-directed lifestyles to DNA-directed lifestyles. That's better medicine through DNA-based techniques. And you drop the serology like a bad habit. It's a bad habit. So drop it and go to DNA testing methods.
Yeah, and this is sort of off topic, but I listened to a podcast with podcaster Tim Ferriss, who actually is someone who is suffering from chronic Lyme disease, and he interviewed a Professor Sinclair from Harvard University, whose daughter was suffering from chronic Lyme disease and actually almost lost her vision. And he's now developing a test where he's testing for all non-human DNA. Do you think that's where we have to go in order to be able to properly diagnose people with all the various microbes that are now sort of creating these chronic conditions that we may or may not be defining as Lyme disease?
Yeah, the idea of multiple DNA chips on DNA tests on one chip is not a new concept. That was under development at Stony Brook years ago when I was still in Long Island. So these DNA chip diagnostic, multi diagnosis on one chip is the future, and DNA diagnosis is the future. And in the World Trade Center, when the people were killed and you had to identify whether they actually were in the building or weren't in the building, you get pieces of people, like a fingernail or a piece of a nose, or a piece of, not the whole patient. And you use DNA tools to say, yes, that is the patient's remains. So DNA is a forensic tool. Forensic means in court of law. And we should use a forensic approach to our diagnosis of tick-borne diseases in all cases. Use the DNA. It's the fastest. It's the most reliable. It's now becoming the most affordable. Do it.
So Dr. MacDonald, talk to us more about, you touched on earlier the connection between Lyme, Alzheimer's, and dementia, and you did a lot of research and study on that. So you can talk to us more in great detail about the correlation between all these different things and how people traditionally think dementia can't be related to Lyme, but really it can be, right?
Yeah, when I came back from Vienna after presenting my dead babies, on the plane back, I had an idea for my research going forward. And in Vienna, I had learned that Lyme disease has stages according to Dr. Packner, primary, early, secondary in the middle, tertiary way out at the end. And so he said, well, it's tertiary forms of Lyme disease. And I said, oh my God, because I remembered from syphilis that tertiary, primary, secondary were the ways that you talk about syphilis. And tertiary was way, way out from infection. And the example of tertiary syphilis was brain dementia. Brain dementia, that's not good. Dementia, brain disease with dementia. And so I said, well, if it can happen in syphilis, tertiary, then tertiary Lyme has to be Alzheimer's disease, period. And I thought everybody in the conference had the same idea, and I was expecting to have lots of risk competition from anybody in the room. They had 200 people in the room who listened to that primary, secondary, tertiary, and they'd all go home and try to find Alzheimer's as a cause of, Borrelia as a cause of Alzheimer's. Didn't happen. But I got the brains from George Weiner's brain bank. He was a big leader in Alzheimer's disease in 1985. They were all frozen. They shipped them. They arrived in dry ice, like a suitcase full of dry ice. I thawed them and I, set up my cultures to see if I could grow the spirochete. I did. 4 of 4, I grew spirochetes from the Alzheimer brains. I did the tissue studies. I found that the spirochetes were present in the areas of Alzheimer's disease, but not in other parts of the brain which didn't have Alzheimer's disease. And I published that in the JAMA, Journal of the American Medical Association, back in 1986. That was the event, you remember, when Dr. Steer said that I probably faked the data, but I got it published. And ever since then, I've been looking at infection causing dementia caused by dementia caused by infection. So if you have AIDS, you can have dementia. If you have syphilis, you can have dementia. And if you have other types of infection that are chronic in the brain, JK virus, you can have dementias. So, and of course, syphilis is the granddaddy of all. So it makes sense that infection can cause dementia. That's not controversial. It's just, does infection cause Alzheimer's? That's radioactive. So that's where I've been struggling to get my work published. And I had some very good work that I had finished from from my time at, I was at St. Catherine's Hospital, and I got a brain from Stony Brook. It was a person who had well recognized Lyme disease, presenting as multiple sclerosis, like atypical facial pain, and then evolved into some problems with walking, and he developed hydrocephalus with a magnetic gait of hydrocephalus. And then they put a shunt in and they treated him with antibiotics because he had Lyme and he had this problem, and the shunt got infected. And during the time he was getting antibiotics for the infection of his brain shunt, his dementia symptoms cleared up. And then after they cleared up the infection of the brain shunt, they stopped the antibiotics, and his infection is returned and his dementia got worse, and he died of Alzheimer's disease. So when they did the autopsy, they just did the, by the book Alzheimer autopsy, and they didn't look for spirochetes. And the widow came to me and said, "Oh, I read about your work. Would you look?" And I said, "Yes," and I did. And I found that there were patches of Borrelia DNA and biofilms in his Alzheimer brain and spirochetes in his Alzheimer brain. So it was residual persistent Borrelia infection in the brain, already diagnosed as Borrelia in the brain at Stony Brook during life, but not, connected with the dementia. And that's how I got started. It took me 16 years to publish that case.
It just sounds so strange to me, though, that
it's 16 years of rejection. Nobody would publish it. Finally got it published this year. 16 years.
But Dr. MacDonald, it just seems so weird that clearly this patient was sick with Lyme disease, developed dementia, was treated with antibiotics, got better from dementia, went off the antibiotics, dementia worsened, and the Alzheimer's, worsened, and he died. I mean, so why would they fail to recognize this clear connection and then take almost 2 decades to recognize your work to properly identify the connection between these things? It seems so weird to me.
Alzheimer's and infection is radioactive. And if you are talking about that, you are radioactive. It's now gaining some credibility because there was an Alzheimer competition around the world. People submitted their work, and there were 8 finalists. I was one of the 8 finalists. So there are people now who are looking at various types of infection as pathways to dementia. And it's now getting to be legitimate almost 30 years after I started my work.
And talk to us more about and I guess the first question should be, are these amyloid plaques you referred to the same thing as biofilms?
Yes, the amyloid that is in the Alzheimer plaques is the way it was always diagnosed. Amyloid-coated plaques are Alzheimer plaques. The new idea is that the amyloid is actually not a toxic thing, but an antimicrobial thing. And it's on the plaques because inside the plaques, it's loaded with infection of biofilm Borrelia. So the biofilm is coated with antibacterial amyloid. And that's why you're seeing it as an amyloid lesion, but it's actually an amyloid antibacterial coated infectious plaque.
So there's this strong substance that has a whole bunch of Borrelia inside of it that's coated with a protective substance that prevents any antimicrobial from getting in and killing the Lyme. And this is what's common in dementia and Alzheimer's. Is that correct?
That's my personal view. That will get you thrown out of any country club in the world.
Well, I mean, you've proven it. So I think, again, in maybe another 16 years or 5 years, they'll then take your work and publish that, and it'll become facts.
Well, we have some possibilities, but I'm not sure it'll happen while I'm alive.
So, but another thing is, you did mention Borrelia, but I think there's another connection. It's not just Borrelia Bergdorferi we're finding in these plaques. There's also Borrelia miyamotoi that you've discovered as well, which kind of gives us some more eye-opening insight, correct?
Yes, that's also radioactive, but that's true. I found miyamotoi mixed with Borrelia Bergdorferi and Alzheimer plaques. And that's okay because you're going to have mixes of miyamotoi and Borrelia Bergdorferi in blood. So it goes from the blood to the brain and sets up its biofilm, and that's how things get started.
But it sort of makes sense why many people in the Lyme community that thought they may have Lyme disease associated with dementia were getting standard Lyme testing, and they were all coming back negative because those standard Lyme tests weren't even looking for Borrelia miyamotoi at the time, right?
Absolutely true. And also biofilms will probably not switch you over from antibody positive or to antibody positive. They'll probably be a way to disguise the infection because it's coated by the stuff outside the biofilm, which is a goo that surrounds the living bugs inside the biofilm. So it has like a protective layer.
So understanding all this, what is the proper treatment protocol for somebody who has these plaques in their brain that's harboring the Lyme bacteria, leading to dementia likely and Alzheimer's potentially? What treatment do you do? Because if this coating is antimicrobial, are antibiotics going to cut it to actually treat these plaques?
It'll need to be worked out, but I think that there are ways that you can penetrate the biofilm and get inside and use a biofilm active antimicrobial protocol. They're actually using things like cancer chemotherapy drugs now in Johns Hopkins to treat biofilm infections in the test tube. So instead of using, like donomycin, which you'd use for chemotherapy, you'd roll it out for treatment of some of these stubborn biofilm things, and they're using other new agents. They're using dapsone, which is an anti-leprosy drug, and they're using other new agents. They're also looking at viruses that prey on spirochetes called bacteriophages. And there are some interesting ideas to use a virus that would prey on the infectious organism and kill it, just like you would kill a human cell. There's viruses that kill infection. So there's all kinds of new modalities coming along, and I'm optimistic that one or more of those will use in the treatment of Alzheimer's coming forward.
So talk to us more about the brain and Lyme and parasites. You studied the brains of MS patients and you made some interesting observations. And although I think they may be a little preliminary, but you did find parasites in the brains of MS patients pretty consistently. Is that correct?
Yes. The MS thing, I got started because I was trying to find spirochetes in the MS brain. And there's a lot of papers from the past century which have linked certain non-syphilitic spirochetes in MS infections. And I did a couple of cases and I found some evidence of spirochetes in MS lesions. So I went and I got a series of spinal fluids from the Boulder, Colorado Multiple Sclerosis National Brain Bank. And they only had a few for me to study. They had about 10 over 30 years. And they sent them all to me because nobody was interested in studying spinal fluid. The rule is, that spinal fluid study in the living or in the dead is useless in multiple sclerosis because everybody knows that there's nothing there. But nobody's actually looked to see if there's nothing there. They just say it's not productive. So I went and I paddled against the stream and, like a salmon swimming up the stream and jumping past the bear that's going to eat you. I looked at the spinal fluids and I found that every single one of them had parasites, but they weren't roundworms, they were tapeworms. And they weren't huge tapeworms, they were minute, minuscule, dwarf tapeworms. Every single patient over a 30-year period had evidence of these novel, minute, dwarf, microscopic tapeworm larvae in the brain fluid. Now, I can't say what was actually in the brain solid tissue because I didn't get solid tissue to look at. I just looked at the spinal fluid, which bathes all the brain tissues. So it's in the brain and spinal fluids in 10 of 10 people over 30 years. And it's a new species, it's a new animal, it's never been seen, never been given a name, but it's a new parasite of the spinal fluid in multiple sclerosis patients. It'll have to be worked out. It might be that it's more than one, it may be a group of organisms. It may be 10 different dwarf agents, but they're all, multiple sclerosis is an environmentally initiated disease. We agree on that. Something in the environment. So it's like present in increased numbers in northern countries like the US-Canadian border and across, there's a multiple sclerosis belt around the planet. So you have it in Norway and you have it in northern England and you have it in Russia and northern climates have excess. Now, if the environmental stimulus, which is unknown, is actually food stuff that has contaminated with worms, tapeworms, and you don't cook your lettuce, you eat it fresh, right? If you could get it from unwashed or insufficiently washed lettuce or fruits or fresh things, that's how it would get into your system. You eat it and it gets into the intestinal tract and it goes from the intestinal tract to the brain. That's my working idea right now, is that this new agent is transmitted by contaminated food.
So people that generally think we live in the United States, we live in a we're not living in a third world country here. That doesn't mean we can't get parasites. We can get parasites from our food and other means. And as a follow-up to that, can we get parasites from a tick bite? Are ticks capable of carrying and transmitting parasites to the human body?
Well, yes. I mean, the spirochete itself is a parasite in some sense, but you can have conventional parasites of the worm type. Dr. Shapi has found, and Dr. Bergdorfer actually found, the microfilarial worm in the guts of the tick from the Shelter Island experiment. So yes, and he had a choice. He did the tick gut dissection. He looked at the microscope. He said, "Oh, there's a big worm, but then over here there's some spirochetes." So he decided to bet the ranch on the spirochetes as being the cause of Lyme, and to shove off the worm as incidental and not contributory. It may be actually that it's contributory too, and then you have a double thing going on: spirochetes and microfilarial worms from infected ticks. I think she had a 10 or 17% incidence of the Lyme ticks, exotic ticks in Connecticut, carrying these little microfilarial worms. So it's something out there.
Now, there's also a symbiotic relationship between these parasites and the Lyme bacteria. Isn't there these round parasites can actually, or these nematode parasites can actually house the Lyme bacteria inside of them, correct?
Who would ever have such a crazy idea as that? I mean, come on. You're talking to me. Who would have an idea like that? Well, I did. And I found out that the worms actually eat the bacteria as food. So, yes. And so they could ride on the outside of the worm, or they could ride inside the worm gut. And, if it's inside the worm and it's living happily inside the worm, and the body doesn't know it's there, then the worm dies and it releases all these bugs inside of the worm guts. And then you have a flare up. And then those get dealt with and they calm down again. Then more worms eat. So there's a worm to bacteria cycle that's possible.
Are the spirochetes alive inside of the nematode parasite, or is it just dead? Yes. And they are alive?
They are. They can be.
They can be. So that's another way that the Lyme bacteria can evade both the immune system and any kind of treatment like antibiotics, because they're hiding inside of a parasite, it sounds like.
Brilliant.
So there's so many layers to this why Lyme testing is inaccurate today. Never mind the antibody testing is just outdated and inaccurate, but also there's so many ways the Lyme bacteria can hide and evade these tests as well. So I think it's important to note that even with the gold standard tests today and the best labs in the world, some doctors still are treating based on clinical diagnoses of Lyme. And that's probably fair to say that that's an acceptable practice. Would you agree?
I think the doctors do the best that they can for their patients, and they want the best for their patients. So if you're with a doctor who is open to the idea that you could also use ivermectin, which is an anti-parasitic medication, then you'll find that they're prescribing ivermectin with some antibiotics for Lyme in some of their patients, because they want to hopefully get a better outcome and modify the immune response or something. And that's completely reasonable in my view.
So we have heard some people, a very small percentage of the people we speak to in the Lyme community, treat for the bacteria with antibiotics or another alternative and an antiparasitic to address these parasites that we're discussing. Why isn't that more common practice when we know parasites can be transmitted from a tick to a human? We know these parasites have a symbiotic relationship with the Lyme bacteria. It seems like we've proven all this, yet we don't treat properly. And that can be another contributing factor to why people don't get better after standard treatment for Lyme disease.
So you asked why?
Correct. Yeah. Why do you believe that current practitioners are not more broadly treating with an antibiotic and an antiparasitic?
Because that idea came from my mouth and I'm not trustworthy.
So, but you have, studies that are proving, and other people besides yourself are proving that these parasites are in the tick gut and can be transmitted to humans. We're finding these parasites in the human brain, and yet they're ignoring your work and many other of your peers' work in the community still.
Yeah, there's an adversary relationship from the powerful to the powerless, and I'm on the powerless side, so I don't have any power.
Well, I think the tide is turning there. Hopefully, I mean, you're making progress, so I think we're starting to see a change there, and I think that's a positive sign.
Well, we want the best for the patients. I mean, I don't care about winning like a Monty Python thing, where you've got the Black Knight and his arms and legs are cut off, and he says, "Come back here, you coward," that kind of thing. I'm waiting for that day to come with some of these Lyme denialists in the community who try to make trouble for advances in patient care.
And talk to us more about these parasites in general. So these parasites are in the brain. What damage are they causing? Are they, I know these nematodes can actually like eat parts of the brain, and they have an anus, and they can excrete stuff. So like, what effect does that have on the human body as a whole when you have these parasites in your brain?
There's a condition called visceral larva migrans, and it's a parasite of perhaps a dog or a non-human that accidentally gets into the human system. And then because it doesn't have its usual target site in the dog or cat or whatever, it meanders through the body tissue, causing havoc, blindness and brain lesions and other lesions and lesions in other parts of the body. So it wanders around, and it is not over until it's dead. And so visceral larval migrans is a legitimate parasitic disease. Now, the ones in my class who didn't want to spend time in parasitology because they want to get on to clinical medicine and that kind of thing, they might not have much credence in that, but it is real. It is a third world disease. And I think we have to be comfortable with a one world view rather than a third world and a US view. We live in a one world now, and people travel and foods get transported across borders and stuff. So we have to live in a one world view. That's why we got somebody with this COVID-19, because it didn't come from us, it came from someplace in Asia. And we have to be able to cope with illnesses that are worldwide. And Lyme disease is a worldwide illness. Well, let's call it borreliosis. It's a worldwide illness. In spite of protestations to the negative, it's like it is present in all continents. And it comes up in different flavors, but it's in South America, it's in Australia, it's in China, it's in, Pacific Island. It's a one world illness. So let's have a one world view and be smart and treat all our patients as if they might have a zebra instead of a horse's hoof when you hear a hoof.
So Dr. MacDonald, let's talk a little bit more about best practices and what types of requests Lyme patients should be making of their doctors, right? You had argued that just like patients when watching advertisements on TV are walking in and asking for a particular drug to treat their condition, that perhaps that's a methodology we should be using in the Lyme community. So if we were to make that recommendation to our listeners, let's first talk about the microbe element or the reduction of the microbe element. Is it your recommendation that our folks walk into their doctors and say, hey, I probably have a polymicrobial infection and I need an antibacterial, I need an antiviral, and I need an antiparasitic to help my body begin to reduce the microbe load that's causing me to be chronically ill?
Well, I think that would be getting ahead of the skis a little bit, because I think what you'd have to start with is a diagnosis. So you would say, I'd like to have some DNA diagnostics for the things that I'm concerned about, which are outside of the availability of clinical labs. The Centers for Disease Control does offer free patient diagnostic services that include DNA studies for both spirochetes and other parasites, and they have an expert diagnostic service that's free. Physicians don't understand all the time that they can send their problem to the CDC and get help. Remember there were 3 hearts that were contaminated with Borrelia that were ready to be transplanted from humans who died suddenly, and they were not permitted to be transplanted. Remember that story?
Yes.
That was the CDC. That wasn't your local hospital lab or your state health department. They sent these to the CDC, and the CDC had the tools to swiftly and accurately diagnose those cases, and that prevented a disaster. So let's start using the CDC more. And if they have to kick up their budget for more incoming work from people around the country in tick-borne diseases, start funding the increase in the CDC. They have the power to do DNA testing. They have the power to do advanced diagnostics in tissue and in blood and other body fluids. So start with that appeal. If I can't get anywhere with ordinary diagnostics with my doctor, the doctor still can petition the CDC to help them with the patient if the doctor is willing to do it. It's free. Do it in the patient interest. You might actually learn something.
Okay, so your first recommendation is that people who are suffering from chronic Lyme disease should be asking their clinicians to utilize the CDC testing that's available.
Yeah, and I'd start with if you have a syndrome that might be neurologic, then send your spinal fluid to the CDC. You'd be amazed what they can do with spinal fluid. Spinal fluid is like an orphan body fluid. Neurologists do some of it, but we don't really. In the era of syphilis, they would have morning spinal fluid taps in the syphilis ward, and look at the spinal fluid and assess the progress of the disease based on what the spinal fluid is doing. That's virtually unknown today. The spinal fluid study should be reinstituted because it has a lot of very valuable stuff that can come out of study of the spinal fluid if you have a neurologic problem. Let's do more biopsies. If you have a heart problem and it's not coming up with any kind of diagnosis, do a right heart biopsy and see if the bug is in the heart. If you have a problem with the liver, do a percutaneous needle biopsy with a CAT scan guidance and get a piece of deep liver and work with that. If you have another organ system like, let's say, spleen or kidney, do tissue biopsies and then send them for molecular studies and let the DNA work in service of you and work in service of educating your doctor. It's free.
Now, while the CDC testing is being done and someone is now looking to prophylactically treat so that they can reduce the microbe load, and we're going to talk about the immune system in a minute, do you recommend that they request an antiviral, an antiparasitic, and an antibacterial medication so that they can have that type of prophylactic protection?
Well, I don't think the prophylactic is quite the right word, but I would not spend as much time thinking about viral. If you're going to do treatment for what is now a bacterial condition, then let's hope that some bacterial active agents could work. If you're going to do something that's parasitic, use parasitic active agents. They're not really dangerous. Just to start out, people have gotten into trouble sometimes with very, very long-term therapies where the IV lines get infected and they get infected with fungus and stuff. But I would open up the idea that a course of antibiotics can, in some patients, change a seronegative lab test to a seropositive test. So you start on antibiotics, and then after antibiotics for 3 weeks or so, you do another round of blood testing, and you may find that the patient becomes seropositive. Sometimes the antibody is hidden inside what's called an immune complex. And that means that the antigen, which is a protein, and the antibody, which is immunoglobulin, lock onto each other, and they don't react in normal antibody detection serologies. But if you bust open the immune complexes, then you have a chance to detect the infection. So some of those things have really paid off for people who had this immune complex disease problem. And one of the things I'm working on right now is that the biofilms, which are chronic colonies of the bug, and they may be in tissue, it may circulate in blood, they may actually function like the immune complexes of smaller size in some patients' immune complex disease. That there's a solid thing, and that's the biofilm, and the antibodies lock onto it because it recognizes the infection, and because it's taken out of solution and now is in a particulate solid form, it is unavailable to be detected by blood testing. So if you open up those things and release the bound antibody, you'll be able to detect it. That's another project in progress in my work right now, is to look at biofilms as immune sinks. You remove the antibodies from the blood because they lock onto the circulating or tissue-bound biofilm, and you become a false negative patient in blood testing.
Let's talk about neurological Lyme and how the neurological Lyme presents differently than it may in other parts of the body, and what you'd recommend from a treatment standpoint for somebody who's suffering from neurological Lyme.
There are many types of neurological. So you have the nerves themselves, the peripheral nerves, and you have the nerves of the head and neck and the cranial nerves. You have the white matter problems. You have the gray matter problems. You have the inside the fluid of the ventricle problems. You have the lining of the brain membrane problems. So there's many different types, many different facets of neurological presentation of Borrelia infection in the human host. So it's a very, very complicated menu to go over.
Okay.
And you would start with the spinal fluid, because the spinal fluid bathes all the tissues. You start with a good spinal fluid sample, and then you would do DNA detection for Borrelia DNA in the spinal fluid. And then you do other tests too. They don't, if you take a spinal fluid specimen, it's 4 tubes. Each one has about half a cc to 1 cc. And the amount of fluid that's necessary to do all the other testing, the cell count and the chemistries and the other things in the spinal fluid antibodies is very small. And you have, at the end of it, leftover spinal fluid that hasn't been used for anything. Use that for DNA testing, or put it away in the freezer and freeze it, and then do another spinal fluid down the road and see if things have changed from specimen 1 to specimen down the road. See if there are changes, see if if the DNA evidence is getting stronger. Use that approach. I would use spinal fluid as a conduit to comprehending what's going on with people who have Borrelia in the nervous system.
What is your opinion about the use of herbal protocols for the treatment of Lyme disease?
I'm not an expert in that. I think that I would defer to the people who are using it. And I think you have to remember digitalis, which is a heart medicine, is an herbal, is this plant extract. And it became manufactured synthetically, but originally it was an extract. So many things like anti-malarials have been plant-related pharmaceuticals. So I think plant-related pharmaceuticals, now they call some of these nutraceuticals, but in medicine, plant-related pharmaceuticals have been very necessary. Chinese medicine is based on a lot of that. I have no expertise in any of that, so I would defer to the people who use it. I can't recommend anyone or any formula.
So what is your perspective on the future of Lyme? I mean, the diagnosis rate is increasing rapidly. We had over 500,000 in the US alone last year. What needs to be done to stave off the growth of this pandemic?
It's a problem not only in the United States, but in Canada. Canada is actually retracing the steps of the United States as the problem moves into, ticks are moving across the border. So Canadian cases are becoming more and more numerous. And in other geographies too, they're having better recognition of tick-borne diseases. I think that you start out with the basics of the earliest and easiest to comprehend, and then you move on to the understanding of the many, many complexities. You have to spend time and keep yourself educated so that you can recognize unusual forms of the disease. Keep your eye open, keep your antenna up, I guess is the right word, so that you can get the TV signal. If you don't have your antenna up, you won't get the TV signal. If you don't read, you won't know that Lyme disease can paralyze both leaflets of the diaphragm and create a breathing problem. Lyme disease can paralyze the larynx. Lyme disease can blind you. Lyme disease can cause deafness. Lyme disease can cause lymphoma-like growths to develop in your body. Some of them are pseudo-lymphomas. In Europe and in Italy, they're real lymphomas. So you have to be a student that wants to learn in order to keep up with all this.
So in the past, you were shunned, and in the past, you were not given access to medical journals, but some of that is beginning to turn the corner. And there are some folks who are, I'll say politely, borrowing some of your work and taking some credit for it, which I think is rude, but on some level encouraging, because they're obviously acknowledging that you are doing good work. And some of what you had discovered in the past is becoming mainstream. And most recently, you discovered that some of the work that you were trying to get published is in fact becoming published, and you discovered some of that today. So talk to us about those changes and whether or not you're beginning to feel vindicated by some of those changes.
Well, I think the wake-up call for this morning is something I'd like to tell you about it.
Please.
I woke up this morning and I looked at the Canadian Lyme site, and I found that there's an article from Columbia Presbyterian with Dr. Fallon's group, which describes detecting Borrelia spirochetes case study with validation among autopsy specimens. I said, ooh, autopsy Lyme and Columbia, what do they find? They found that a patient who had Lewy body disease in the brain and whose disease was preceded by past episode of Lyme disease many years before, up to 14 years before, still had Borrelia DNA and Borrelia proteins in the Lewy body autopsy brain. And I said, wow, that's an eye-opener. That's not quite Alzheimer's, but it's a dementia. And it's a connection between Borrelia infection and a brain degeneration. And I said, wow, that is so wonderful. In 2015, 2016, I published a poster, which is entitled Diffuse Cortical Lewy Body Dementia, 2 cases linked by fish DNA hybridization studies and immunohistochemistry to tertiary Borrelia in the Lewy body brain. I don't know whether Columbia was aware of that poster. I got it published way back when, but I'm glad that they've done their work, because now I'm going to resubmit this poster to be considered by maybe the New England Journal of Medicine. If Columbia has paved the way for me, maybe I can get this very new article into old article into a new journal. It's fascinating. It's heartwarming. It makes an old man smile.
Well, it's making this old man, who's a little bit younger than you, smile, and young man Matt smile as well. So of course, that sort of ties back to what we were talking about before, which is the importance of getting this type of research published in mainstream journals so that the standard of care can change, and clinicians would then have the freedom to treat people the way we deserve to be treated.
There's a nice kind of a flashback in syphilis. It was around for 500 years, and it had so many different ways it could present in human infection. The skin and the dead babies and the bone and the eye and the ear and the liver and every single organ, the aorta, everything in the body could be affected by syphilis. The last thing that was brought under the approved by the medical profession manifestation of syphilis was one condition. What do you think that was? General paresis, dementia of the insane. Brain rot was the last thing that was brought into the syphilis approved category of medical practice. And the person who did that, who broke through that barrier, because up until that time, they said, well, the people can have syphilis, but they can also have old age disease of the brain, and they're not connected. And there was a guy named Hideo Noguchi, who was a wonderful researcher at the Rockefeller. And he decided to look at some autopsy brains. And he found that in people who have died in sanitariums, in Long Island, like Pilgrim State and the big ones, took their brains and analyzed, and they found that Borrelia spirochetes were present in the syphilitic brain. And that opened up the whole thing for treating people who had general paresis dementia of syphilis with antibiotics. And that made them candidates for therapy, and many of them were cured. I'm doing the same thing that Gucci did with Alzheimer's disease. And now I'm going to be doing it with Lewy body disease. And maybe if I'd gotten a chance to get in with Robin Williams before he got really, really sick, maybe he could have been rescued, maybe, with some antibiotics. Just maybe. I'll never know.
Dr. MacDonald, I did want to share with you that somebody had reached out to us recently talking about Robin Williams and the role maybe parasites and Lyme and co-infections could have played in his health issues. So what are your thoughts on that?
When he died, I wanted a piece of his brain very, 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 very badly, because I'd already published my Lewy body and Borrelia poster. And people on the West Coast who had some influence tried to get me to get connected to the people who had the access to the tissue, and it didn't work. But it is fixed, it's put away, it's in formalin, it's not gone, it just hasn't been reopened. So it's like, maybe someday I'll be able to get some of the preserved tissue and see if that was a connection. I'd love to know.
So I do just have to kind of follow up on something we touched on earlier, which is the whole Lyme and cancer connection. So you've done some preliminary studies that show that cancer tumors have not only Borrelia in them, but also these nematode parasites as well. So what is that? What do you think that really means? Do you think there's a connection? Do you think that's a coincidence? Or do you think that really further research needs to be performed before we can kind of make any conclusions on this?
You're kind of opening up the door to the glioblastoma work that I've done. Is that what you're opening up for me?
Yes.
Okay. Lonnie Bennett is a friend who died this year, and she was a campaigner for better Lyme disease care, and she was a friend of Willie Bergdorfer, and she worked very hard for physician education. She noticed years ago, maybe 10, 15 years ago, that in her Lyme circle of friends with chronic illness, there seemed to be too many brain tumor deaths. And so she postulated that there might be a connection between the chronic infection of Borrelia and the brain tumors. And it took me a while to kind of get my act together, but I did contact a friend who was a pathologist, is a pathologist in Long Island and Brookhaven. And I was able to get tissues from brain tumor biopsies from 5 Long Island patients who had glioblastoma. And they were all dead at the time because, rules for education and research and stuff. So it was a dead person's brain glioblastoma study. And I used my DNA probes for Borrelia DNA to see if there might be some spirochetes in these glioblastoma tumors to go along with Mrs. Bonnie Bennett's idea that they could be related. And all of them lit up like a Christmas tree. All the brain tumor biopsies lit up like a Christmas tree. There was Borrelia DNA all over the place, but it wasn't inside these spirochetal forms. It was like in a big glob here and a big glob there. And I thought, gee, maybe I did something wrong. Maybe I got like, I just didn't do the research right. So I repeated it, and it held up. And then I finally realized that what I was looking at in these big globs of Borrelia DNA in the glioblastoma tumor biopsies was biofilm DNA. And so I came up with the discovery that just like the biofilms of certain kinds of bacteria in the colon can start colon cancer by sitting on the colon tissue and causing the tissue to go to malignant, that biofilms of Borrelia in brain can also stimulate the induction of a malignancy of glial cells, causing glioblastoma multiforme. Now, the first person I want to tell about this story right now is Joe Biden. I want the president to know about this one for obvious reasons. And I want Mrs. McCain to know about this discovery. And I want other people who have lost their dear family members to glioblastoma to maybe go back and have the hospital autopsy send some of that stuff to me so I can see if their brains also have Borrelia biofilms in those glioblastoma tumors. And if that's true, then there will be antibiotic, in part, therapy for glioblastomas. But that has to be done with some bigger studies. But I got 5 of 5 cases. And I've got an idea that the biofilm, big glob, can do nasty things in tissue. And biofilms of E. coli and colon can cause colon cancer. And biofilms of Borrelia in brain can cause glial brain malignancies, glioblastomas. Biofilms in the European acrodermatitis lesion, where the skin gets paper thin, can sprout squamous cancers. And they have biofilms in those lesions too. So some Borrelia biofilms could actually, when they sit on a tumor site, cause the tumor to grow. That will also get me expelled from any country club.
So Dr. MacDonald, as far as the testing that you're using to look at this is not standard testing, right? So your fish testing that you do, it requires a certain methodology that's just not being done by other people. And is that why you believe others aren't finding this connection, because they're not doing the same testing that you're doing, right?
Yeah, there was a lot of work for me to become molecular. You know, I used to be silver stains, then I used to be antibody stains, and I got better and better. And then I decided, the future is like in the graduate, it was like plastics. Remember plastics in the graduate? That was like the growth industry. For me, it's molecular DNA. That's the growth industry. So I had to acquire some DNA skills, and it took me about 4 or 5 years to get up to speed. And now I'm really outfitted with a lot of DNA probes that are Borrelia related, Borrelia focused. And they are wonderful, wonderful things. And I've given them away to people who have used them in their research, and they've raved about how good they are, because they can find Borrelia forms that don't pop up with other types of stains. So they really give you a better version of what's actually going on in truth in the diseased tissue. So the DNA diagnostics are the way to go. And it's like forensic. It's admissible in a court of law, and it can't be shouted down by the opposite side. DNA rules.
So it's a definitive test, and it can't be said that this is a false positive, like is said in many cases with the antibody testing, correct?
Absolutely.
So
there
I do want
no false positive DNA test if it's properly done. 0.
So I do want to follow up. You did talk about, mother to child transmission of Borrelia, and that's sort of been widely accepted now in the Lyme community. But another controversial topic is sexually transmitted Lyme disease. And one of the things we learned while researching you in preparation for this podcast is that there are some studies that aren't really well known out there, specifically a study that was done showing that in, I think, dogs it was, that Lyme was transmitted from sexual transmission from one dog to another. So can you speak more about what your beliefs are, understanding that there's really no definitive answer yet, but do you believe that Lyme disease can be sexually transmitted from one partner to another?
Yes, I do. Remember that in the day, in order to get a marriage license, when syphilis was in its heyday, you would have to have a blood test. And the blood test wasn't for mononucleosis. The blood test was for syphilis. And if you had a negative blood test and, both sides negative, then you could get a marriage license. And if either side was positive, no marriage license was issued. Why? Because they weren't really super focused on the adult patients. They were focused on the potential unborn infant, right? And so that's an example of sexual transmission of a spirochetal disease from one partner to another. Now, if it can happen in syphilis, it can happen in borreliosis, period. End of sentence. If it can happen in syphilis, it can happen in borreliosis. And I don't need to go through all the other whys and wherefores. I was in on the research which Stricker and company did, and which was shouted down by the naysayers, but it's good evidence. And they showed that in some partners, they had the same, male and female had the same infection, although neither of them had a tick bite, neither of them had Lyme disease, but they had DNA evidence of the infection in their sexual body fluids. So DNA rules again. And what is ordinary and non-controversial in syphilis, sexual transmission, should be ordinary and non-controversial in Lyme disease, borreliosis, period.
So sort of related to that topic, Dr. MacDonald, is you were involved in a study where a man was tested after being on consistent antibiotics for almost 7 years, and you found various strains of the Lyme bacteria in both his testicles and his brain, in addition to nematode eggs as well. So why do you think that Lyme persisted in this particular case study in this gentleman's brain and testicles after almost 7 years of continuous antibiotic treatment? And what does that mean for everybody else who's listening to this?
I think you're talking about the Minnesota
Yes.
man who lives in the woods and who was very sick. Yeah, so you're absolutely right. And he was a casualty. I don't know why he didn't get a better result, but I think that biofilms are more difficult to eradicate than single spirochetes. So when you go from single spirochete early disease to biofilm in chronic disease, you hit a brick wall, because the ordinary doses of antibiotics and the antibiotics which were being used back then, and remember now we're using cancer chemotherapy drugs on biofilm Lyme, but back then they were just using oral penicillins. He didn't have a chance, because once he got to biofilms and he didn't get a biofilm program that was effective, he was toast. And so that's what happened to him. And it was in the pre-biofilm era, but he does have biofilms in his autopsy tissue. He also was from Minnesota, and he had a Minnesota strain of Borrelia mayonnae in his autopsy tissue. It's the first case in the world of that.
Dr. MacDonald, I want to take you back for a second to the dementia issues that we were discussing. I recently saw a piece on 60 Minutes. I shouldn't say recently, sometime in the last year, where there was an NIH-sponsored study of a community in Florida, a study where all the citizens before they moved into this community had to go through a battery of tests, and they were very fit, and it was this sort of this fit community. And then 30 years later, when this community aged, people began to donate their brains to be studied by the NIH and the NIH sponsored study. And what the researcher was looking to determine is what factors would make it more likely that someone would suffer from dementia or not. And part of what she argued in the 60 Minutes piece was that it looked like dementia was a series of mini strokes that were causing brain die-off. Do you think she may be wrong about that? And what she was really observing was portions of the brain that were dying off as a result of biofilm, and that this sort of collectively developed to the point where there was large-scale brain die-off and brain dysfunction?
Well, multi-infarction dementia has been around and established in people who have conditions where the blood vessels are diseased. So that's one of the established types of subcategories of dementia, is a multi-infarction pattern of dementia. So you, little by little, rather than having a big stroke, you have lots of little areas of injury, and the brain tissue disappears as each one of those events proceeds. Now, since my biofilm work has not gotten to the point where I have access to that type of brain tissue, I can't tell you whether there are any connections between Borrelia biofilms or maybe other infection biofilms. Remember, E. coli and other things can make biofilm too, so it's not the only biofilm on the block. But if a bacterial biofilm could move from the blood to the brain and then hit a capillary where it can't get across, it will cause tissue injury or death. So that would be like a mini stroke. And if you have a whole bunch of biofilms, then you have a whole bunch of mini strokes. And that's a pathway which hasn't really been considered very much. You'd think of cholesterol, crud, as the cause of strokes and blood vessels and brain and many strokes and stuff like that. But there's also an amyloid connection where you can have an amyloid disease deposit, and it weakens the blood vessel, and then you can get hemorrhage from that. And I've got some research now underway where I have a patient who died of Alzheimer's disease. It's not controversial. I found that there were Borrelia spirochetes in the brain, but I also looked at the blood vessels, and I found that some of them had what's called congophilic angiopathy, which is a amyloid deposit of this gummy substance in the wall of the blood vessel, and then it weakens it, and they have injuries there and problems. And in that amyloid, just by luck of the draw, I found that there were Borrelia proteins inside the amyloid gunk. What does that make you think of? It makes me think of biofilm remnants covered with amyloid, right? And so I think that that's another fertile area of investigation to see whether congophilic blood vessel disease in the brain is due to recurrent amyloid emboli that hit a vascular bed and cause blood vessel disease and then cause mini strokes. And then if you really want to get out into the ether, you know, on this, you could say that little strokes outside the brain might happen in people who have biofilm concentrations in the blood. And so when the biofilm hits an area in the muscle or an area in the bone or an area in the other soft tissue, and they get total body pain. What could that be? That could be a shower of amyloid-coated biofilms in the blood from some infection and not a psychiatric condition. That'll also get me ejected from any country club in the planet.
Well, it sounds to me like you really wouldn't want to join any club that would have you anyway. So it's probably
that's the Woody Allen. Yes, I'm all Woody Allen all the time, right?
So you've been really generous with your time, but I have two more questions that I have to ask you, and then we will again thank you for being so generous with so much of what you've shared with us. The second to last question I want to ask you is where are the places that are offering you hope? I mean, there's much to be depressed about with this growing pandemic. There's much to be concerned about, but where are the places where you are finding the greatest hope that we will make progress in overcoming the suffering caused by Lyme disease?
I think that the research advances as they stack up are going to open up new areas of thinking, and then new thinking will be new areas of better diagnosis. So my friend Eva Shoppe at the University of New Haven has done a lot of incredible work in biofilms, and will continue to do that. Dr. Eisendel and his colleagues in Europe, the Europeans are doing great work. The Europeans are way ahead of us in many dimensions, and Borrelia disease. They were the first to put cardiomyopathies on the map from Lyme disease. And you'll remember that Neil Spector, who was a wonderful, wonderful man,
yes,
Lyme, he had a heart transplant because his heart was destroyed by Lyme. He recently died tragically of a viral condition, but he had to have a heart transplant because his heart was so diseased. So, you add all these other components up, and you see that we must escape from the tyrannical view that Lyme disease is easy to treat, hard to get, never chronic, and never fatal. You have to get away from that and understand that it's a bigger condition. It's just like syphilis. And syphilis is a nasty bug, not to be trifled with. And let's adopt a syphilis mentality for all of the people who have chronic conditions due to Borrelia. Let's approach them as if we were treating syphilis, and then do the right thing for them and give them the support and the therapy that they need. You got to do that. So it's a paradigm shift. You just go from syphilis is gone to syphilis is still here. It's not gone. It may be forgotten, but it's not gone. And the real syphilis is coming back in the gay and gay community and in the third world community. And it's becoming an emerging repeat public health problem. So syphilis is still here. And we are now dealing with the tick-borne syphilis equivalent in the Borrelia Lyme arena.
So now I'm going to ask you the final question we ask all of our guests, and that is, if God forbid, one of your family members came walking in your room right after you finished this podcast and they discovered a tick that was biting them, what would you recommend that they do so they wouldn't have to be concerned about going on a chronic Lyme disease journey?
Well, you have to know what species of tick it is first. I mean, you want to know whether it's a dog tick or an exoded tick or whatever. And if it's an exoded tick, then you want to intervene, like my friend Dr. Ken Ligner. He intervenes and he gives them some coverage to get through the first few weeks after that, to make sure, just in case, that they suppress anything that they could suppress. Now, the antibiotics will not suppress everything. It will not suppress babesiosis. It will not suppress ehrlichiosis or anaplasmosis. So, you have a chance at making a little bit of a dent if there's big time infection in the little tick. But at least you have a mindset that maybe the patient will need follow-up care. And if not, file it away. You can have your tick analyzed if you want. I'm not sure all the analysis labs are equally good, but you could have it analyzed. If you were going to have it analyzed, like do a DNA analysis. And that would be the earliest clue as to what's really in that tick. If there's nothing, there's nothing. If the DNA tells you there is something, then deal with it. So let your DNA be your friend. And I'll save the tick, and start them off on something. It couldn't hurt. That's Bronx for it couldn't hurt.
Thank you for listening to the Tick Bootcamp interview with Dr. Alan MacDonald. To our listeners, we have a call to action. First, if you'd like to learn more about Dr. MacDonald's and his work, please visit his website at alzheimersborreliosis.net. Second, if you enjoyed this episode of the Tick Bootcamp podcast, please share it with your friends by using the social media buttons you see at the bottom of the post. Third, Tick Bootcamp has created a Tick Bite blueprint that has been inspired by the information that has been provided to us by past podcast guests. We urge you to visit our website at www.tickbootcamp.com to view the blueprint. Please note we would appreciate any input or any improvements you would like to offer. Fourth, don't forget to subscribe to this podcast on iTunes, Google Play Music, or Spotify to get your automatic episode updates of our Tick Bootcamp podcast. And finally, we thank your community for your comments on our past podcast episodes. Please take a minute to leave us an honest review on iTunes, on Instagram, or on our website. We make it a point to read every single one of the reviews we get. Thank you, as always, for listening.